assume your surface are smooth。我们所有刚才的都是假设你的面是 smooth surface。Those material I provide additional， 我是额外的提供给你们 ，because they are very useful when in the real factor will confront this kind of the problem. You'll find it based on the design. You have every design is good. Why? They have some of the problem is beyond your expectation. OK， 它为什么会发生？你没有办法 ，you cannot anticipate why you have this kind of problem because you have evaluate all the things. That's because your surface roughness isn't taken into account in your design. So how to correct this surface roughness in your design? 你怎么样去纠正、改正 ？That's become important. Okay. So those material I just give you the brief introduction. How to design, take the roughness effect into your problem. So that is what we talk about here. Here, you have to determine the C maxima fin thickness. 我们希望就得到你的 C 值是针对最大的。We hope our C value in this C value have the maxima fin thickness as the problem, like this one. And here they have a C maximum. But our C value choose this value. So use this plot. 你用这个 figure 12.4 and the optimization 就是 this figure. If you have, then you can determine C maxima for this value. OK， 这个最好的设计就是这个。All right， 这个是 based on your this figure and then this figure. OK， combine together to determine your C value for your design. OK， the first thing is, but this value is based on those plot or those figure are evaluate, assume your surface are smooth. 你得到的到目前为止，你算出来的 C 值，是你假设你的面是一个没有粗糙度的，但实际情况是有。这个问题我在2个公司I have met this problem after 2 different companies, the same problem. Okay, just running a period of time, they find that they have a surface scoring. 表面有磨损掉了，擦损掉了。Why? That's because this C value actually is not correct. 所以我们从那边得到的 C 值，是假设你的面是没有粗糙度的，那我现在要把它改一下，OK, all right. And then from this figure, this should be this block should be put in the first as the first block. Okay, this block. Okay, put it here, move it to here. All right. Then 我们然后用这个 figure 12.2 to obtain this value. This as subscript means it's a smooth surface. Okay, here. R, I mean the rough surface. the subscript from this figure will obtain this value, and then C is obtained because your C is obtained first. Then put it here, then you obtain the H minimum for your smooth surface. 所以从这个第二个 block， 我们得到这个 H minimum for the smooth surface. Alright? Okay? Now it put here. Now it's very important. We call the similarity. In fluid mechanics, we have the one chapter talk about the similarity, right? Okay, what do you mean by similarity? It means that any parameter are dimensionless. 我们的这一个所有的参数是 dimensionless parameter. We call it P. Okay? P may be the temperature, maybe the velocity, maybe a different parameter. Alright? We call it P. Alright? And then we talk about the prototype and the model. Prototype 就是原型。什么叫原型？实际的情况。What is the model? Model 就是模型。比如一个飞机 ，for example, what is mean by prototype? For a jet fly, okay? They fly in the real condition, but we cannot, put our experiment in the real condition. So we put the model inside of the library. 我们把这个模型放在一个实验室。Using the experiment method to simulate the real condition. We obtain the data in the model. We made the experiments, and then we measure some of the data from the laboratory. Okay. Due to you use the model to obtain the experiment data. Then the next one is just that we have to transfer to the real case. It means that you have to transfer your data to be in the practical case, in the real case. 我们称为 prototype. 我们在模型是在实验室里面得到的，模型得到的这个数据，我怎样转移到这个原型上面去 ？OK， 那这种 transformation between the prototype and then the model, we call the similarity. So we have three kind of similarity. One is for the geometric similarity. (几何相似是什么呢？就是我们的几何 prototype and then the model, if they have the similarity, okay, we talk about geometry 就是几何相似 okay, maybe the prototype and the model, the size is different, but the shape, they are same, 形状是相同的，大小 size may be different, but the shape are different. Okay. So we call the geometric similarity. The second, we call the kinetic similarity. Kinetic similarity. This kinematic or kinematic. This kinematic similarity is that velocity similarity. 凡是明白的 kinetic similarity. In the jet, fly in the real case, maybe 1 hour is just 2,000 kilometers. Okay, but in our experiment in the laboratory, we cannot create the real condition. Maybe have our model jet in the water or in some of the air, right? But the air velocity are quite different from the real case. In the real jet, fly in the real circumstance. Okay. So in this case, first the relationship, first the transformation between the velocity in the model and in the real prototype. Okay, what is the transformation? This transformation we call the kinematic similarity. So kinematic similarity means that velocity similarity. And the third similarity, we call the dynamic similarity. This dynamic similarity means that the force similarity. First, mean by force similarity. You measure the force, different force, in the level, in the model, we got it from the experiment, right? Now, the problem is that how to transfer this force into the real case. In the real case, the force, of course, different from the model case, right? So in the prototype, the force, how to determine the prototype force? You can obtain the model force. Model force then based on we call the dynamic similarity to transform into the prototype case. 我们要利用实验的这个部分，再加上所谓的 dynamic similarity， 转移到真实的情况，得到真实的一个力量。所以 three similarity allow us to have the prototype and our model have the transformation. We find that based on this, if these three similarity are satisfied, then we say P is property or parameter you need for the prototype equal to your P for the model. For your model. Alright? 这个观念，如果这三个 if these three similarity are satisfied, you guarantee that any P value for the prototype equal to the P value for the model. All the P are dimensionless, 它是无因次的。无因次。Okay, alright. Now we need this one only. We don't need these two. Because we want to study the surface roughness behavior. Surface roughness is a geometric factor. It's a geometric parameter. So we just need this one. First model here. Model here is our smooth surface. But in real application, prototype is the rough surface. Alright? So we use the geometric similarity. Now allow your smooth surface geometric parameter equal to the rough surface. Equal to the parameter of the rough surface. Okay. But this parameter, 这个参数 should be dimensionless. 无因子. Okay. So how to do it? We got the C, we got the H minimum from these two steps, right? This is H minimum, this is C. These two values are obtained in the smooth surface. 这个是我们得到的。First, we need to determine this one. C from the chart, we can determine the C value. But it's assume your surface is smooth. But in your surface, you cannot prepare your surface to be so smooth without any roughness. Impossible, right? So you have to choose this one. If this value obtained, congratulations, everything you can do. So keep on, please keep in mind. 很多人这个心不在焉啊。你念书以前念只是为了学历，我会说你绝对是失败人士。I never care about my degree for the past 40 years. I never. I got my PhD degree in United States. Okay, very famous university, but I never sent it again. I just look forward for my future. I do everything very hard. Just for your future. I never have the way mask for due to I have the PhD degree. It doesn't make any sense. So you study something. Why you studied this course? You need this knowledge to your business in your future, not just for the degree, for the score of this course. Keep in mind, you cannot wear the mask forever. 你不能戴着这个面具永远戴着。But your knowledge in the reality, just demo your performance in your company or in your workplace. 所以这个就是你要用它啊。好 ，geometric similarity. H is length, C is also length, so it's dimensionless. For the small case, this ratio is equal to this one because we are showing this geometric similarity. It's very, very important. Okay, so you study another course or the other course, but some idea can be introduced into different area. Okay. First, knowledge. Knowledge is not come from the textbook. Textbook is common sense. It's not knowledge, because everybody can get it without any problem just by you read it. But the knowledge is come from your thought. How to obtain your thought? 怎么样得到你的一些想法 You read something, and then also try to use this something into the another field. 这个才是真正的知识。这个来自 geometry come from the similarity. You have your full mechanism, right? 所以几何相似道是我们有这个东西。所以这个呢，转成这个。You need to determine this, right? And now CS we have obtained from the choice, okay, from that figure. The problem is why is this one? H minima for the rough surface and the H minima for the smooth surface. What is the ratio value? How to determine it? If I can determine it, this is available. 这个已经得到了。这个如果得到的话，我就决定了这个真正的细致。How to obtain it? Okay, now here this value, I can write this way. I can write this way. 看着啊 ，OK. 这个我写成这个 h minimum rough is h minimum smooth surface times the function we call the f. F is the function of sigma r or sigma s. First sigma we call the standard deviation. Why we need the standard deviation? 标准差。Why we needed this function to be the function of the standard deviation? That's because I got the literature. 我得到一个文献。The literature is just the published paper. The published paper, I will show you. You read it in that published paper. They show this problem. They show this roughness parameter in terms of standard deviation. 在那篇论文里面，它的这一个粗糙度的参数，它是用标准差，而不是一般的表面的平均粗糙度。In that published paper, they use the standard deviation instead of the roughness to present this result. Those results are experimental results. 他们所有的资料是由实验来得到的。Okay, so that literature I try to show you. Then we try to solve this function. If this function is available, then everything is obtained. Then you can determine this. 所以现在我们现在来决定这一个函数。这个函数呢 ，this function I show you here in advance. Okay, or find it. This function is function of standard deviation for the rough and the smooth surface. And then I obtained it to be this value. Why it is this value? Then it's the next one. Okay, so here is the variable. Then put it here. Put it here. And then times this one. Then you obtain this one. Then you can obtain CR. Okay, so this function. How to obtain this function? Now is the next one. Okay, yeah, all right. The reference factor on journal value, we want to determine function of sigma r over sigma s. All right. Here is this paper. You can use the Google to obtain this paper. It's published in the Tripology International. It's a very famous journal, high rank journal for tripology. Okay, so it is published in 2018. Okay, right? And then in that paper, in this figure, I got the 3 data. The 3 data from the experiment data in this paper. 在这篇论文里面 we have a standard deviation. Because that paper, all the results are evaluated based on the experiment data, 就是由实验来得到的。So they prepare different surface for the journal value. For the surface, okay, we come to it. The standard deviation, not the mean surface roughness, 它是标准差。First, the standard deviation, I will talk about it. Okay. And then they also have 3 corresponding minimum fan thickness for this one. There's major directive. Okay. There's a specimen surface roughness parameter. First, the standard deviation. Let me show you. Here is the definition of the standard deviation. 这是标准差的基本定义。Okay, let me show you. Okay. You measure the surface with the profile. Look like this. Like surface roughness. Okay? Then here is the X. And then you measure the surface for a period of time or period of the space. 它一段这个位置里面得到的表面粗糙是这样。And then we can obtain the mean surface roughness for this one. This we call the mean value. Okay, right? This is the mean value. What's the mean value? The volume or the area above this mean line and below the mean line, they are equal. 我们的中心线这个平均线就是在这平均线上面的体积或面积，跟在这个平均线底下的面积或体积 ，they are equal. So it's very easy to use computer to determine this value if this surface profile are available. 很容易得到这个面。好，我们的任何一个 local 的量，随便一个量，或者这个量，都是一样。这个呢，我们称为 x。有的时候是在腹部，有的在胸部。OK， 这是真实的它的量。它的平均量是 x 八，然后我们把这个量就切了好多好多，而有不同的 xi 值，是不是？那看这个啊，这个是 xi， 看你切了多少份 ，xi 减掉你的平均值，然后给它平均，不是给它平方，平方以后再给它平均。这个就是 standard deviation 标准差。Standard deviation for the surface roughness is very important. If you are the student of the material science, the particle size for a quantity of for amount of the particle, maybe the size is different, right? Somebody will ask you, it's very important. What is the mean size of this particle, your particle you provide? How do you determine it? That's very, very important. Then what is the standard deviation? Okay. If standard deviation is small, you mean that your particle size are uniform, right? More uniform. Very, very important. You hope you prepare your material to be good material, good quality, then standard deviation of your particle size should be small as possible. Okay, keep in mind. 所以标准差越小，表示这个粗糙度越平均，或者这个 particle size， 这个 particle 的大小越平均。So from here, if you have a surface reference, you can use this equation to obtain the standard deviation. All right? Now come back to here. I got 3 set of the data. 3个从这个论文里面得到的 data standard deviation 跟 minimum principles for your journal value. Okay? 这个论文 if you need the paper, I hope that you use the Google to obtain it. All right? Read it. some of the knowledge not from the textbook, from different literature, especially the newly published paper. Very, very important. Okay, when you start the United States or any the renowned country, renowned university, you'll find how to get the literature data become very, very important in the progress of your research. I guarantee. Okay. So here we have this one. So we have the regression, 我们去回归 to obtain the expression to establish the H minima and our standard deviation. 我们想要利用这个数据去建立一个数学式子，去建立这个最小油蒙度跟 standard deviation 的这个量。We have a three set, so we give our polynomial to be the second order. The order is 2. Then we have a ABC. ABC are unknown, but we can use this three set data to obtain the ABC. So put here to this one. We have this one. The second is this one, and the third is this one. Then from the algebraic equation, 我们从这个代数的这个式子 we can determine ABC to be here. So H minima should be this value. Is function of the standard deviation. Okay? All right. That's it. All just come from the experiment data. In that paper, use the standard deviation. I cannot get the mean surface roughness. In this case, I just based on the standard deviation. OK， 那清楚吗？它提供 standard deviation， 我没有这个表面粗糙度，那我也只好用the standard deviation. OK， so that is function. OK， now we continue. Here, we needed this one. We have to determine the f function, right? Here, h minima, s mean the surface is real perfect surface, so no roughness. 我们在这个样子假设它没有这一个粗糙度 ，but in the nature, we don't have the surface without any surface roughness. So, if we assume S is perfect smooth, it's not realistic. Okay, 它是不实际的。So we have to choose some of the smooth roughness as the smooth surface. Understand? 我们要选一个很小的粗糙度的效应。In real case, we should have any surface have the more or less the surface roughness, even if it's small. But actually, it's not zero. So the real perfect smooth surface is not existent. So we have to choose some base. The base means that the surface roughness we can consider, we can regard it as to be smooth surface. 我们可以考虑很小的粗糙度，当做它的粗糙度 ，OK， 当做它的 perfect。All right, understand? All right. Here, then here we determine to be this one. And then here sigma r and then sigma s. Here is s. All right. Sigma or sigma s. This sigma s, not zero. If it's a perfect smooth surface, it is zero. But it is not realistic. Okay. So in this case, we have to choose one surface. This surface roughness is small, with the small roughness enough. sufficient small or roughness. In this case, we have the corresponding H minima. Okay. In here, for my data, just from the data, okay, from the experiment data, we choose this value. Our standard deviation, 0.1 micrometer. In this case, there is H minima, it's 4.45. It's come from this literature. 这同样来自这个文献，我们假设这个0.1，它得到的 H minima 是这个值。This value, these two values are the basis of the smooth surface in our case. OK， 所以我们这个量把它选为这个我们的这个最小的这个粗糙度，就是假设它是 smooth 的 surface。OK， all right. So in this case, all the sigma s over h the minimum for the smooth surface are based on this value. Okay. So in this case, now we want to determine this one. This h minima is this value. No, you put it in here. Okay. Based on this value, this is for smooth surface base. Okay. Now we want to determine this one. We also have a 3 set of the experiment data, like the previous one. Right? You know, the chip is not so fast, so reaction cannot keep in pace. So the logic, okay, is same on us, okay, because in Taiwan, the chip is most advanced around the world. But the computer is okay, because this computer has a long time, notebook very long time. So we have a 3 minima fin thickness set. Okay. So we use this data then to determine the F. So we want to determine. So we assume that F to be the order of the polynomial with the largest order is the second, the 2. Like this. We want to determine A, B, C. Alright. Okay? Now, this denominator, the standard deviation and the minimum phase thickness, we use the 1.1 as the standard deviation for smooth surface. Okay, this is the corresponding minimum phase thickness. All right. Now we have the 3 set of value. We'll put the 3 set of the experiment data. One is the 0.5 for this value, and the next 0.7 standard deviation with the standard with the minimum phase thickness of this value. You'll find it's very interesting. Okay? Your surface roughness increase, 你的表面粗糙度 increase, your minimum phase thickness will increase or decrease. This is smooth roughness is this value. And then you have a minimum phase thickness of this value. Now you change your surface standard deviation to be this value. Then your minimum phase thickness reduce. So write down. Okay? You increase your surface roughness. You will decrease your minimum phase thickness. Okay? You have increase your minimum phase. You have increase your surface roughness. You will decrease your minimum fin thickness. If you decrease your minimum fin thickness, it's very dangerous, like the damage I have shown in last lecture. Your temperature and so on will increase, will rise. So we have 3 sets of the data. Okay, then we obtain the 3 algebraic equation. 3 sets. There's the denominator we are shown 0.1 micron as the standard deviation of the perfect smooth surface. 这分母的部分是用0.1的，我们不可能有0的。用0的话，这个变无穷大了。好，得到就解解。You obtain the ABC. Okay, use computer. Maybe not need 1 second to obtain the ABC. Then congratulations, everything is good. This we call the correction factor. 矫正因子。破坏 your H minima you obtain from the smooth surface, then times this value. 你的这个表面粗糙度假设是一个 perfect 的，就完全这个平滑的这个最小薄膜厚度，乘以这个量，就得到一个新的有粗糙度效应的量。OK， 讲清楚吗 ？OK， so this function has been obtained. Everything is okay. You show smile. Okay, so return to here. Quickly, please. So please read it after class, okay? It is useful, okay? In the design. You have a smooth clearance, right? This correspond to your H minimum. Then times your function. Then you obtain the real clearance you need. 讲清楚吗？帅哥？不要听得模模糊糊，有没有清楚？这个是从这边得到的，但是这个表是用在 smooth surface。你现在又有了这个函数，回去读一下，得到以后这个一乘的话，就得到有粗糙度效应下的这个西子。OK， 所以 choose your clearance for the rough surface. In respect that your surface roughness is high or low, okay? But you can use this function to correct your clearance choice. 你的这个西子的这个选择，你可以根据这个。Okay, there's additional material I offer for you. Please use it. Okay? And then in one day, you got something, you have things. Alright, this chapter stops here. I don't know whether we have the homework. Today you will submit the homework or next? Huh? I remember there's one chapter, just one exercise. When you are submitting? You have submitted?
Me, I told you that I put for the next week, but I think
OK， 下一次的有一张是一条题目的那个，把它教一下。OK， 好了。Okay, do the homework for this chapter. 一条就好。12.63，里面有没有那个？有没有？有没有这个 homework 的部分？有吗？有吗？有哈，12.63，要做啊，这个将来你们才会有感觉。是。哦，那10分钟。